Hello everyone and welcome back. Today we're going to be looking at electric fields. So what are electric fields? Electric fields is a region of space around a charged particle through which a force is exerted on another charged particle. Think of, let's say for example, like a football field. It is what? It's an open area, an open space. Well, this is the same thing. So an electric field is a region of space around a charge whereby if you place another charged particle, it will experience a force. So we're still looking at static charges, meaning not moving charges, but now we're looking to see what's going on around them. So electric field strength is given by the following simple formula. Electric field strength symbolized by E equals F of E, that's the electrostatic force that it's going to experience, divided by Q, which is the Coulombic charge. So now, let's go into my trusty sketchbook and let's look at this in a little bit of greater detail. So what exactly an electric field is? So let's say we have a charge. Around this charge, and of course it's not moving, so the velocity of course is zero. Around this charge, it's going a field, an electric field will be set up. And in that field, if you put another charge, let's say in this case, I'm putting a positive charge, it is going to experience an electrostatic force. In this case, because it's negative and positive, opposites attract, it is going to experience an attractive electrostatic force. On the other hand, if we put now another charged particle, let's say negative, remember the same repel, so it's going to experience a repulsive electrostatic force and it's going to go away. So this happens all within this, as you can see, this dotted line, this dotted circle, that's where the electric field is. If now you place another charge that is outside this field, guess what? It is not going to experience any electrostatic force. That means it will not accelerate and therefore its velocity will not change, or it will simply remain zero. So that's basically what an electric field is. So now let's look at the quantitative relationships between the electric field. So we said electric field strength is given by the following formula, which is F of E, which is the electrostatic force, divided of course by Q, which is the Coulombic charge that an object experiences. So over here we have two relationships that we need to explore. The first one is electric field strength, and of course F of E. So if we look at them and we try to plot them, we're going to see, if you remember correctly, numerator, that is going to be directly proportional. So the relationship that these two variables will experience is going to be directly proportional. And everybody remembers, of course, what is direct proportionality. If you're graphing it, it is going to be a straight line going up like that at regular intervals. And it makes perfect sense. The greater the electric field strength, the greater the force that a charge it's going to experience. It's completely common sense. Now, on the other hand, we can also explore this relationship right over here between electric field strength and, of course, the Coulombic charge. And because this is numerator denominator, if you recall correctly, that is going to be inversely proportional. So inversely proportional. So now, if you recall correctly, the graph of that, it is going to be one that curves downwards like that. So so if the charge is low, we can experience a greater electric field strength, and vice versa. If the electric field strength is low, it is going to experience a greater Coulombic charge. So going back to our presentation, let's look at a problem right now. So let's say we have a problem like this. We have to calculate the magnitude of the electric field strength at a point in a field where an electron experiences a force of a magnitude 1 times 10 to the negative 15 newtons. So the F of E that it experiences is 1 times 10 to the negative 15. So going back, of course, to our sketchbook, let's just open up a new one, clear this out quickly, and let's see. So we said that the electrostatic force that the electron's going to experience is going to be 1 times 10 to the negative 15 newtons. So, as we know, electric field strength is going to be the electrostatic force that it experiences divided by the Coulombic charge. So now, we're trying to find now the electric field strength. That's what the question asked. So the electrostatic force it experiences, we put it right on top under F of V. So 1 times 10 to the negative 15 newtons. And now we have to remember what is the Coulombic charge on one electron. And if you guess that it's the elementary charge, you guess correctly. So that is going to be, of course, 1.6 times 10 to the negative 19 coulombs. So if you put these two numbers in your calculator and you divide it, you're going to simply see that it's going to be 6.3 times 10 to the third newtons per coulomb. And that is our answer. That is, of course, the electric field strength. So 1 unit of Coulombic charge, it is going to experience 6.3 times 10 to the third newtons. Thank you very much. See you guys soon.